All right, so we're recording now. Let me get our lesson back up. We're doing lesson 1.1 in our Algebra 1 books. This is variables and expressions. If you want to follow along in your books, you can open up to page 4, the one after we were just on. All right. Vocabulary, we're going to talk about some different words that we need to know of. One is quantity. You guys have all, I'm sure, have heard of quantity once or twice. Quantity is anything that can be measured or counted. And while you guys are writing that down, let's try to think of some things that have quantity. All right, Isaac. Cargo, yeah, because I mean you have to load up cargo, and you can measure cargo in different types of quantity, right? You could have number of boxes, right? That's a quantity, or the weight, right? That'd also be a quantity, something that can be measured, right? Anybody else having one? Yeah. Huh? What was it? Water. How would you measure water? Measuring cup would be one way, right? How many cups of water do you need to make a, some type of food, right? Also, gallons, right? What was that one? I didn't hear it. All right. Anybody else? Trees? You're going to go count the trees alongside the highway? No? Fruit? You can also. So those are all things that can be quantities that can be counted. That one's off. There we go. Variable. A variable is a symbol that represents a value of an unknown quantity. Okay? An unknown quantity. Sometimes things aren't known to us. Right? We can't use a number to represent it, right? So here I ask how many ducks. I see some people actually trying to count them all right now. Right? But what if you don't know how many ducks there are? Could we give it a variable? Yeah, we could give it a variable. How many ducks? Right now, I don't know, so I'm going to call it a variable. Let's say D. All right, D. Then, somebody's counting. Has anybody got it down, all the ducks yet? So D is just a placeholder for the quantity until we know the actual quantity. Okay. So, I need to fix my board real quick. 76, you say? Okay, I'm not going to double check your counting, but let's say there's 76. So D is a placeholder, right? It just holds the place of a number until we know what that number is. So it's going to stay D until we know that the number is 76. So then I'm going to put equals 76, and then that replaces the variable with the number, telling us the actual quantity. All right? Okay, we have some other vocab here. One is algebraic expression. Right? And we have this word algebraic. What's algebraic sound like? Algebra, right? It actually says it right there, algebra, right? So what algebraic means is we have a mathematical phrase with variables and numbers and symbols and all that, like 2x minus 7, right? And you can tell when it's an algebraic one because it will look like algebra. Opposed to algebraic expression, we also have numerical expression, right? A numerical expression. Numerical expression, is it okay if I go down that far? Numerical expression is the same exact thing, but there's no algebra in this one, is there? What's numerical sound like? Number, right? So it's just numbers and symbols, right? So an example of that would be 2 minus 7, right? It could also be plus or divide or anything like that. Now, what big part of math are we missing on both these? Do you guys notice anything that's missing, a symbol that's missing on each one of these? Yeah, equal. Usually we see a equal sign, right? But these are just expressions, okay? An expression is just half of a problem. Right? It's not an equation. All right. So an equal sign is not necessary to be an expression. All right. Now here we have, it's kind of, there we go. Can we see that? All right. So I have the 4 symbols. All right, let's bring that one up. The 4 math symbols that we're really used to using, right? That's addition, subtraction, multiplication, and division. Okay. Then on the left-hand side, I have a bunch of words. Those are kind of math words that we'll use in word problems and when we want to just talk to somebody about the math. So what I want to do is I want to put these different words into which operation they belong with. Okay. So if you see one that you think you know where it goes, go ahead and raise your hand, Colton. Yeah, go ahead and come up here and move more want to do it. Oh, now more people want to do it. Elvis, you can go next. Good. All right. Haley, you're after Colton, or not after Colton, after Elvis. All right. William, you can go after that. After this. And then we'll go Cole, Vladimir, Ryan. There you go. And then you'll be after Ryan. Go ahead and come up and get in line so it doesn't take so long. Twice a number, good. Yeah. Don't let your finger bounce on it. What are you doing? You're gonna. Yeah. There you go. Who else? Go ahead. You're next. I need 2 more volunteers. There we go. You're next. Last one, anyone? Oh, if I'm going to let somebody go twice. You do the last one. You don't know the difference? Oh, let's ask the class. Which one do you think the difference is? Which one of these 4? Yeah, I think it's subtraction, right? The difference, if I say what's the difference between our 2 heights, we're going to subtract 2 heights to find out what's the space in between. Good. We're going to be using all these words in word problems and when we're communicating and stuff like that. All right, so this is problem 1 on page 4. Now in these books, they say problem 1, 2, 3, and 4 instead of examples. But just think of when I say problem, it's like example 1 in the book. So it's not like an actual homework problem, it's an example. What they did is they gave us a sentence. What we want to do is I want to take this and change it to an expression, an algebraic expression. So this one says 32 more than a number n. 32 more than a number n. So let's see what this means. So first off, I'm going to underline the math parts of it, okay? Obviously 32, because that's a number, right? What else? Well, yeah, the plus part, which is more than, right? We said that was a plus operation. And then a number, and they said that it's not x, they said a number n, right? So they told us the variable. But if they didn't tell us, then yeah, we could use whatever one we wanted to. We could use x, p, o, q, whatever. So now we're just going to put these in together. So we have 32 more than a number n. Right. Just changing it to expressions. All right. Here we have 58 less a number n. All right. What's some of the math stuff in this one? Yeah, the 58. And then less a number means take away. And then number n, that's our variable. So we have 58 less a number n. Okay. Now, here's a key point that we need to be aware of. Most of the time, we're going to be writing these expressions from left to right, just like here we did 58, right? 58 less a number n, left to right, just like the words. There is one that we need to be careful of because it's actually flip-flopped. Okay. Here I have 58 less than a number n, right? All I added was one word. Yeah, than. That than. What? Now I still have. That word right there actually changes the algebraic expression from 58 minus n to, so that one's the only one that you need to be aware of and make sure that you don't get caught up on it, okay? So less than means you need to flip-flop them. Less means it's okay, right? Now I know it sounds, it's a little bit confusing. Why isn't it all the same? It's just the way that the wording is and the way that it has to be, okay? So just be aware of that. All right, so we have problem 2 on page 5. For part A, it says 8 times a number n. All right, what's the operation here? Times, right? Multiplication. All right. What's my variable? N, and then what's my constant? 8. So I have 8 times letter n. Now, that's perfectly okay way to write. How else could I write this? Yeah, 8 n, or even 8 n. As we go into algebra, we're going to move away from this times symbol and move towards those other two. Okay? Because what does times symbol look a lot alike? A variable of x, right? So we don't want people to get confused and think this is 8x n. We want them to know it's 8 times n or 8 times n. One of those two. Okay, so move away from the x and move to the dot. All right, B, the quotient of a number n and 5. All right, what operation is this one? Divide. All right, so this is divide. All right, and what number's going to go first? N, yeah, or x, but here they told us n. So n divided by, 5. Or, yeah, or n over 5, right? That's also divide, right? Because fractions are just divisions, right? So either one of those would be just fine. All right, now, let me ask you here, how is 8 times a number different than 8 times a number n? The variable, right? The first one, 8 times a number n, they told you the variable has to be what? N. If they don't tell you, you get to make up your own. So you can use x, a lot of people like x, you can use y, you can use a or b, whatever floats your boat, right? Does it change your answer at all? No, because the variable is only a placeholder, right? It doesn't matter what the letter is. It's just a placeholder. All right, number 3, problem 3. We're coming up with some more expressions. So let's try to get through these. A is 3 more than twice a number. Now this is a little bit more because what operations do you guys hear in there? Yeah, plus, and then twice a number is multiplication. All right, so then So you're saying that we're going to drop down the 3, right? So we have 3 plus, and then for a number we have x. And then what are we multiplying x by, though? 2, because twice means 2, right? So it's going to be twice the number, and then when I write that all nice like, it's going to be 3 plus 2x, like that, right? How about 9 less than the quotient of 6 and a number? What are my operations that happen here? Oh, let's tell me one. Tell me one of the operations that we're doing here. Taken away, right? Right here, less than. It's taken away. All right. And Eddie, why don't you help me with another one? Another operation, right? There's one more operation in there. Yeah, right here, quotient. All right. All right. From here, we just need to make sure we plug everything in. Now, is there anything I need to be aware of on this one? Anything special about this one? Yeah, the than, right? Whenever you see less than, you know that you need to flip it around. So, instead of going left to right, I'm going to have to make sure I have the quotient first and then the minus afterwards. So I'm going to have 6 divided by a number. What number do you guys want to use, or what variable do you guys want to use? X, okay. X less than, what was the number there, the constant? 9? 9. So that's one way it could look. What's another way I could write it that means the same thing, it just looks a little bit different? All right? What was the way that we said that we could rewrite this part here? Yeah. There we go. Either one of those two works fine. Okay? All right, C, the product of 4 and the sum of a number and 7. Okay, so what are my two operations happening here? All right, first operation is what? Jose? Yeah. What operation? You don't know? You don't see any words in here that sound like operations? Sum, what's that one mean? There we go. Okay, Heidi. Product, what's that one? Yeah, so we have multiplication and addition in this one, all right? So this one we have the product of 4 and the sum of a number and 7, right? So we have a variable in 7. So we plug this in, right? We have 4 multiply a number and 7. So it looks like what I want to do is do this 4. Let me give myself a little more space. 4 times a number plus 7. Well, there's going to be a problem with that, and there's a problem with what I just wrote. Okay? Right here, I want to multiply 4 by the sum, right? So it means I want to add before I multiply, okay? Because if they want to multiply by the answer of this. So we need to make sure we add before we multiply. How can I make sure I add before I multiply? And it comes with grouping symbols, okay? Because it doesn't say the product of 4 and a number added to 7. It says it wants to take 4 and multiply it by the sum. So we need to make sure we find the sum before we multiply. Okay, so make sure you put the grouping symbols in there. All right? Is everybody okay with that one? All right. So there's a couple little things that you need to make sure of. One is the grouping symbols, and the other is less than, right? Do you need to flip them around if you say more than? If I say like, let's say 8 more than a number? Do I need to write the number first and then 8 second? No? Does it matter if you do? Yeah, addition doesn't matter, right? So addition's okay, but subtraction matters, right? Because of what's 2 plus 3? What's 3 plus 2? 5. So it's okay to be a little bit sloppy with addition. But let's do, what's 3 minus 2? What's 2 minus 3? Are those the same answer? No, so you have to be really careful with the subtractions. Okay? All right. Now, here they're going to give us an expression, we're going to come up with the words to go along with it. Now, is there only one answer for these word phrases? No, remember how many words we drug to the operations earlier? There's lots of different ways we could say this. So if the expression is 3x, what's a word phrase, right? Well, first off, what's the operation happening on A? Times. So how could I write this in a word phrase? 3 times x would be going, right? And the way that they were writing it, they say 3 times a number. Yes, I'll let you write just 3 times x. However, when you look in the back of the book, if you're trying to check your answers, right, it's going to say 3 times a number. And it might say like a number n or whatever like that. But it's okay if you say just 3 times x, because if we know that x is a variable. B, what operation is happening here? Plus. What's a word that means plus? Sum, right? So I could say, how would I word that? I wouldn't say x sum 8.1. The sum of, right? The sum of x and 8.1. All right. C has 2 operations. What are they? Multiplication and addition. So how would I do this one? What words are we going to use? Product. Okay, so you're going to say the product of 10 and x then what? Am I done? Now I need to do the other operation too, which is 9, which sum would work, but the way I wrote it, I don't think sum's going to sound right in there, right? The product of 10 and x sum 9. Yeah, we'll say plus, more than, any of those. I'm going to say more than. More than 9. Right. Now there's, like we were just talking, there's many ways that you can write these. So if you check your answers in the back of the book, they might have something different, but it doesn't mean you're wrong. All right. Another thing that we're going to do is we're going to be writing a rule to describe a pattern. Okay. So on this one, let's see. So in this one, we have levels and then a height in inches. And this was if you look in your book, it's got a picture of a card house, right? Like a deck of cards playing house. So they're talking about the height in inches of this card house. Right? So what they did is if they had 2 levels, they're going to multiply 2 by 3.5, then add 24. That 24 is because it's sitting on top of a desk, 24 inches tall. Right. 3, it's going to do 3.5 times 3 plus 24. 4 is 3.5 times 4 plus 24. So if I'm going to have n levels, what's my rule going to be over here? What's my equation going to be? My expression? The same? Is that how many levels I have right now? 5 levels? N, because we don't know how many levels, right? So it's a placeholder. Times n, then what? Plus 24. So if we have this expression, it'll allow us to figure out how tall it will be if we have 5, 6, 7, 10, 20 levels. Okay, good. So today? We do, because we just finished with notes. All right, we have 9 through 39 odd, 41 through 52, 56 through 66. Now, you guys have a minute left of class, right? A minute left of class? Are you guys going to be able to get all these problems done in a minute? No, I'll give you guys a little bit of time tomorrow. You'll get about, we'll say 20 to 30 minutes, depending on you guys, okay? If you're going to use your time or not. And then this will be due, I guess, next Monday then, right? All right.